This video is a quick review of how to factor by the grouping method. So we've got three examples here, starting with number 1. The grouping method is useful when you have an expression that is 4 terms. So here's how we do grouping. And again, this would be useful for anything that is 4 terms. Looking at number 1, it's called grouping because what you want to do is group your first two and your second two terms together. And then from here, you're going to basically use the GCF method in both quantities. So is there a GCF in the first two terms? In that first quantity? Yes, there is. You can factor out an x. That would leave you with an a plus b. And then see if there's a GCF in your second two terms. So in that second quantity, I can factor out a y. So out in front of that quantity, taking that GCF out, y in front, that would leave me with an a plus b. Whenever you are doing the grouping method, this is important, those quantities you have behind your two GCFs always need to match. They need to be the same. So from here to finish up the grouping method, I would take my two GCFs, put them in one quantity, and then that common quantity goes right behind it. It would be the same thing, so that would be my answer. I could also write it the other way, because remember, you can multiply in either way. You can put either one first. So, either one is acceptable, but basically your GCFs go in one quantity, common quantity goes next to it. In the second example, thing to notice here is that your third term is negative. You can't just throw parentheses in there and separate the first two and the last two. Watch out when your third term is negative. So when you group this, your first two get grouped together, put a plus sign in between both groupings so that that minus sign gets shifted into the parentheses. That's very important. You don't want to keep that minus outside there. It gets grouped with the term. So always put a plus sign in between your two groupings. And again, just GCF both groupings here. I can divide a 2 into both terms as well as an x squared. So that would leave me with 2x as my first GCF. Inside parentheses, I'd have 2x minus, well, that's the whole term being divided out, so that would be minus 1. Now, out of the next two terms, notice I'm almost identical already with those two quantities. It's just that the signs are reversed. When that happens, your GCF you're going to want to factor out is a negative 1. If you factor out a negative 1, you're going to want to have a 2x positive there now, and that plus 1 would now become a negative 1. Factoring out a negative 1 always switches your signs. So again, those two quantities need to match. They do in this case. So my GCFs would go in one quantity, common quantity behind. One more example. What you want to take note in with number 3 is that it's not written in standard form. It's not written in highest power descending down to your constant. So let's rewrite it before we do any grouping. Degree 3 first, followed by the degree 2 term, followed by my linear term, ending with my constant. So now that I have it written in standard form in order, now I can group. Notice my third term is negative, so when I group, I want to make sure I put that plus sign in between the two quantities and make sure that negative gets carried into that quantity with the term. GCF, both quantities, I can divide both of those by 2 and an x squared. So factor out the 2x squared. You're left with just an x for my first term, minus 8 divided by 2 is 4. X's cancel. So there you go, x minus 4. Now the second term, notice again, I need to have a minus 4 as my second term in that binomial coming up. Notice my second term here is a plus 12. So that sign is opposite of what I need. So I'm going to want to factor out a negative. And I notice I have 3 and 12 here. I can divide them both by 3. So what I want to do is factor out a negative 3 so I can switch those signs. So then I'll have negative 3 as my GCF. That would cause me to have a positive x here and a negative 4 there, matching those two quantities up. So my final answer would be 2x squared minus 3 in one quantity, x minus 4 in the other quantity. And lastly, you can always check your answer by distributing these back out and see if you get the original problem. I'll take number 2 for example. If I were to double check my answer, I would distribute. Oops. Looking at my 4-term answer there, does it match my original expression for number 2? Yes, it does. So I would know I factored correctly. You don't have to check every time, but it's something nice to do if you're not sure about your answer. So there is factoring by the grouping method.